Welcome back to the Live Coding Alliance. My name is Cale. I founded the Thingamabobber, and we're doing some TypeScript stuff, making a 64-bit UUID generator based off of a distributed random number generator. And right now I've been working on the groundwork for a neural network based random number generator that simultaneously generates prime numbers. So I need to, get the code into the files where it's supposed to go. I have it down. I downloaded it yesterday. I have not verified that this code is 100% legit. It's just some prime number generator with a lot of downloads. So it's probably legit. The goal is to use a worker thread to have this prime number generator gradient descent algorithm running. And so I've never done multi-threaded in JavaScript, and so we have to do something to figure that out. Me. So the goal is to do back propagation slowly. So I don't want it to consume a lot of resources. I just would like the system to be able to generate these numbers without having a large overhead for a web server. I think it's acceptable for a web server to have one thread that is completely dedicated to running a gradient descent algorithm. I think that's okay. Yeah, I'm definitely a little bit worried that it's going to be a monstrous amount of CPU used for that. So I'm just going to stick to the original design, which what am I trying to say? The design that I had uses a lot of memory, like up to 2 megabytes, and then it still requires the thing to be full of random numbers. So, for the first X random numbers you're generating, like under 2,000, then it's going to be more CPU. But we would want to do that regardless. So the idea is not that we don't have your standard cryptographically secure random number generator. Which I'm not 100% sure the difference between a quasi-random number generator and cryptographically secure. I think cryptographically secure just means that you just can't hack it. You can't predict the next number. And then a quasi-random number it's spread out in the domain in a random way. I think that's the way it works. So what are we doing? we're going to try to innovate on top of this, but get the product done first. So let's get hacking on this code. Oh, right. So this is supposed to be over here, right? Oh gosh. What am I gonna do? I have a keyboard shortcut that keeps messing up. But I don't really want to fix that right now. Whenever I want to like comment code out, it glitches out. So I changed this to a number. Message event. Or do I need to do a big one? Oh god, already. So like, this is it's gonna make a copy of it. Okay. Okay, so it's making a copy of things. So what do I have to do? Wouldn't I want to generate all of the random numbers in this thread for initialization? Because I think the way it's going to work is that this thread has to keep going the entire time. Is it posting happy birthday? Huh. So what does this need to do? Be like a big int? Or can I do a number array? Question is, what's going to work better, a number array or a big int? All right, I don't know. So when I post message, what do I do? Wouldn't do that, obviously. It would have to be, I could do that. On message, log, receive. The problem with this is that I'm gonna need to fix the other thing to get up to the point where I can use that. I started from scratch. And not the one that I want, huh? Generator. So I think what I want to do with this thread is just a random prime generator. Random array. Let's see, I can fix that real quick with the import RNG from Where'd that other... This one. Just do that. Pass it in as a function pointer. I like being able to do that because it makes it nice and easy. So this is a number 6. I have a function for that. I don't really like this guy's code. He has like a library for all these little functions, and it's, you put all of his code together, it's like one file, right? And then he's got this split up into like 4 different or 5 different npm packages. Like, dude, what are you doing? Yes, you need all that extra white space because you can't program worth a goddamn shit. Well, I need to because I can't see it. Don't make that everybody else's problem, bro. Shit, wasting all kinds of time with your junk, garbage bullshit. Sorry, I'm a minimalistic dude. I hate doing shit like that. Formatting. But only has to be done once. I stopped using an auto formatter whenever I learned how to program with the shit. I don't particularly want to have to be fighting a script every single time and just not have my code be the way that I want it. So the plan is to, while I generate these things, I want to calculate an intermediary number. One other thing I have to do is I have to convert these because this guy just doesn't know what he's doing, dude. He's got all these values like as a big int. It's like, dude, what are you doing, bro? I gotta run this algorithm over and over and over and over again. All these values are gonna be 10 bits, so we're just gonna convert them to hex. I'm gonna store them in, or I could just do I could use a function that creates this. Yeah, I'm not going to do hex because I just don't want to convert. I could do one big int that has all of these values. It'd be a while to set that up. Another option, I could just get rid of the end and just probably not going to make way. It's going to know interpreted language, so it's going to be having some issues with performance. I don't really want to deal with this right now. So I need a function pointer to do something with an intermediate value here. So what is this fast mod exponent? What is it? This guy. Okay, so this code is to generate arbitrary sized prime numbers. So I can convert his code. I could just give up on the big N because I don't want to deal with that. I'm already using enough CPU with the numbers. See, I don't want any of this stuff. Type information. I'm unfamiliar with what he's doing here with the. Is this just a function prototype when you do it like this, right? Oh, see, he's converting them to a big int and then doing this. I just don't really want to do this at all. Okay. Just do the ends in here. I hate when that happens. Yellow. Yellow. Damn you. Results. Okay, so that shouldn't do it. Natural. The right one. Damn it, I guess I could use a different thing. That's fucking ridiculous. Do that. So that's my. I'm just go to the bathroom real quick. So we want this thing is 17. I really like the AI suggestion. They get in the way. Random big int. Um, forgot what. So what do I do with the... One option is to have a circular buffer of samples. And then I can take that, like I could take 64 samples and then I can use a 64-bit number in order to perform calculations based on some sort of randomness. Really, I think I need to have like a graph that I'm outputting the output of the algorithm, because I could come up with random ways to scramble up bits. So I'm blue in the face. And so I need to add one. I don't know if I want to do that, but I like fancy mojo that makes my life easier. I can optimize that later, I guess. Bit count. Do I want to do a random number generator pool? So what's the point of this? The point of this is I was assigning random numbers in a blockchain. I don't really want to work on this. I just wanted to compile and maybe not too bad. Okay. Better than what it was. Um, uh, you know why I would have this be. Oh, it's because it's in bit range. So what am I doing here? Am I generating a 64-bit random integer? It's not how you generate random numbers. You generate random numbers using values 0 through 1 because it's a probability thing. And then if you want to generate the other random bits, you would use random numbers. You have to convert the random numbers into a probability distribution. Okay, so the area under the bell curve has to be 1. Sorry, that's the camera. So if the area under the bell curve is not 1, you got problems, right? Number in range. Number in bit range. What is this? Okay, so this is where I'm a little bit okay. Random. Wouldn't do this, huh? Let's fix that. Huh? What is this? Argument expected 1 to 2, and then I got 3. Oh shit, son. What the hell is going on here? Why would I want this? I don't think that I want this. I think that I'm just kind of being an idiot right now. So I want a random number. No, I want a random probability, don't I? So a random number is going to be in the entire range. There's a problem with that in that there is a signed exponent. So that signed exponent is not symmetrical. There is one more negative value than there is positive value in the floating point exponent. So this could be utilized to do a number of things. Oh. Okay, so wouldn't I just need to, hold on, it can't be 0. Is there a number in Z? All right. So -1 to 1. Why did I do this? So what do? You add up 12 random numbers and then you subtract. After 0 to 1, you would subtract 6 from it in order to get to the midpoint. There's also another method that I learned about. What is it? Circular polar rejection? Circular polar rejection random number. What is the thing? Let me find this real quick. Oh shoot. Applying keyboard shortcuts. I gotta do it in the cryptography. Random numbers. And then let's just open them all up, huh? Oops. We're kind of doing a Monte Carlo technique, but slightly different. I mean, I'm just calculating up some standard deviations. But we're looking for circular polar rejection. Why do I have inner product in? I don't think that was supposed to have that one. No. And we could just do watch this one dude's video. Is this it? Here it is. The Marsaglia polar method. Okay, so what are we doing? S, like S domain? Probably not S domain. X over square root x, y over square root s represent the cosine and sine of the angle of that vector. Okay. It was Laplace. That dude was pretty smart. All right. Got this one open. I need another one. Wait, so where's the mojo coming from here? Like, what's the seed? This is just this transform, right? And it's a Laplace, which is the, it's an oscillation. So we got this e to the x. We're in the complex plane here. E to the negative 1/2. What is that, like some? I just don't understand where the seat's coming from. Normally distributed samples. Okay. Mapping from a probability distribution to the complex plane? Is that what's going on? But where's the seat come from? This guy knows what he's talking about, dude.
Generating whose properties approximate the property. Then there are empty spaces. So it's important to remember that, of course, both these variables every point we graph equally we've got to picture the unit circle here. So we've got x1 squared plus x2 squared is less than 1. So everything falls within the boundaries of the unit circle coordinates. So picture the unit circle,
sorry.
and we have
I think
our coordinate 0, 0. Pairs.
Sorry,
So I've coded.
I guess we don't have the desktop audio. Oh, right, desktop audio is muted.
That up in our polar rejection function here, and we've got this while loop. So while any, and I'm using.
Sorry, desktop's not working right here. What do we got to do?
Using NumPy arrays here, so we've got this sum of squared function, which is able to calculate the W, and then we're looking for the condition where this.
Sorry. I'm just going to keep it on the mic because I got to mute the mic.
Numbers, our pairs of variables, is greater than or equal to 1. And while we still have that true, then.
So this is like a refining method. This isn't the kind of method that I'm after. I might want to do this. So, so this is just a filtering technique, right? And so the length, whenever you convert it, so what does this rely on, like some other kind of random number generator? Okay, so what is he doing? So we have a sample. We are going to find the standard deviation of the sample. So we need to subtract each of the points in the distribution and then square that and sum all of the differences squared. Okay, and this is the point where the random number being between 0 and 1 really helps because it's a probability. The downside of this is that the bits aren't being fully exploited because you're not using the sign bit. So this is like a 62-bit random number generator that he's doing. I would like to have a fully 64-bit. I don't know exactly how I would go about implementing. Well, you would still. I don't think you could do a fully 64-bit. I think you could do a 63-bit because the problem is that you got that extra negative exponent. So the extra negative exponent, probably just better to throw that away because it will cause, it can cause your system to have a lot of problems. So you got a negative exponent. So what does that mean? You know, like 2 to the negative 8. What does that mean? That means that you take your floating point number and then you shift it to the left. So that the because you got a hidden bit in your float. You got an exponent, you got a sign bit. Okay? So the exponent is going to shift the bits left or right, just like if you had an exponent 10 times 10 to the negative 5th, right? That's like 0.0003, right? Because you had a 10 and then you shifted it 5. So then it was point, and then you ended up with like 3 decimal places. Same thing with the float. All right, so all right. Well, this thing is definitely turning out to be more complicated than really what I wanted to do. So what is the, going back to the thread, I just started in on this whole like sub project yesterday to do the multi-threaded. The goal is to do gradient descent. So when I got a number array, okay, and then so what do we have? We have a base number array we have input count. Wait, I don't want to do that. Please. Woo. Okay. So I need to have a write-up of the format. Always starts out super basic. Famous last words, right? It's gonna be super basic, bro. Okay. No. Wait. The data. Information about the information. What am I looking for? Okay. I don't know if I want to do. I could just make them all the same size. This would be like an auto ML thing. This is one thing that I don't really necessarily want to have to do this for. I feel like it's a little bit of a distraction, but my gut says I have a neural network. I have a bunch of weights in my neural network. Okay. And these weights require intermediate calculations. It can require a back propagation algorithm. And gotta have at least one hidden layer. Okay. So what is the count then? What would I have to do? Like, all right. What are we doing with the? Where's the weight? So what do I gotta do? We gotta go through and um what do we gotta do? Oops. All my keyboard shortcuts disappeared. It caused such a problem. Still never really fixed them. What am I looking for? Trigger. I don't know exactly what I'm doing, other than doing a really slow neural network. I mean, my goal is to try to like my goal is to do the back propagation algorithm and then use that to calculate pseudo random numbers. So, what do we do? Don't I need weights? Where's my weights at? Is that in the base? So the base, what is the base? It's like my neural network inputs. Well, yeah, let's call it inputs. Then it won't be so confusing because I honestly feel like my brain is melting just thinking about this. What the hell? The hell? Man, this AI code stuff's kind of annoying. And then what the bias is? Wait, no. What am I doing? There's the bias here, and then right. So layer metadata. Okay. The hell I oops, what did I just do? Don't ask me what I just did. Base. Isn't this biases? Base. Bias. All right, I'm gonna hop off the stream because I'm not really feeling very good right now. I'm gonna come back on in just a little bit.